मैम आपका माइक ऑफ है।
Okay, so thank you for letting me know. Okay, so we're starting the topic of probability today. This is the formula you're familiar with. You've done this in your IGCSEs. Probability of an event E is equals to favorable outcomes divided by total number of outcomes. For example, probability of getting a head in when you throw a coin would be favorable outcomes are only one. Favorable outcome is 1 divided by total number of outcomes. The total outcomes are 2 when you flip a coin. So there are only 2 outcomes out of which head is the favorable outcome. So probability of getting a head would be 1 over 2. Probability of getting a 1 in a dice throw would be 1 over 6. Probability of getting a 6 in a dice throw and then another 6 in a dice throw would be 1 by 6 for the first 6 times 1 by 6 for the other 6, so 1 by 36. Okay, we all know this from our IGCSEs. Okay, what about the probability of getting a 6 or a 1? Probability of getting a 6 or a 1. Then you have two options. Either you could do this directly. Favorable outcomes are 2 out of total outcomes are 6 when you throw a dice. So 1/3 should be the answer.
And can you repeat the last one?
Probability of getting a 6 or a 1. 1, 2, 3, 4, 5, and 6. So 1. Just a second. Guys, can you hear me properly?
Yes, ma'am.
Acha, guys, give me a second, please. Okay. Acha ji. So favorable outcomes are now two outcomes, this 6 and this 1. So it's going to be 2 out of 6. Another way of doing this is knowing that OR is plus. So find the probability of getting a 6, then add a plus sign and find the probability of getting a 1. So 1 by 6 plus 1 by 6 will also give us the same answer, 2 by 6, which is 1/3. Okay. So this was a quick recap of the very, very basics of probabilities from IGCSE. Now we're going to talk about mutually exclusive events. Now, what are mutually exclusive events? Events that cannot happen at the same time are called mutually exclusive events. Or events that cannot occur simultaneously. Events that can not occur simultaneously. Are called mutually exclusive events. Example would be if we flip a coin, you can either get a head or a tail. ऐसे नहीं हो सकता कि head भी आए और tail भी आए. So these are two mutually exclusive events. They cannot occur at the same time. इसी तरह, if you throw a dice and getting even number on the throw or odd number on the throw, these are also two mutually exclusive events. या even number आएगा throw पे या odd number आएगा, दोनों इकट्ठे नहीं आ सकते. So that's also another example of two mutually exclusive events. Getting an even score on a dice throw or getting an odd score on the dice throw. These also are mutually exclusive events. They cannot occur together. So if I try to show that on a Venn diagram, this would be event A and event B would be drawn separately. There will be no overlapping region. These are called mutually exclusive events A and B. This represents that if you have to find probability of A union B, this is also read as probability A or B, then that is equals to probability of A plus probability of B. So if two events are mutually exclusive, then probability of A union B, also known as probability of A or B, is equals to probability of A plus probability of B. Okay. Let me show you the Venn diagram representation of two non-mutually exclusive events. So if we have non-mutually exclusive events, non-mutually exclusive events, okay, so we make a box. Inside we make two overlapping circles representing A and B. Okay. So these two are two non-mutually exclusive events. They can occur simultaneously. Example could be getting an even score on a dice throw or getting a prime number on a dice throw. Can you think of a case जिसमें ये दोनों इकट्ठे हो रहे हैं, even number भी हो और prime number भी हो? 2. Yes. So hence these are not mutually exclusive events. They can occur simultaneously if you get a 2. Okay. So in this case, the equation is probability A union B, also read as probability A or B, is probability of A plus probability of B minus probability of A intersection B. ये जो intersecting part होता है ना, इसको subtract करना. ठीक है, probability of A प्लस प्रोबेबिलिटी ऑफ बी, बट ओवरलैपिंग पार्ट की प्रोबेबिलिटी सबट्रैक्ट करनी होती है। Now from this we draw a very important conclusion. For mutually exclusive events, A and B, if A and B are mutually exclusive, then they have no intersecting region between them. So then probability of A intersection B is equals to 0. This is a very important conclusion. ये आपको याद होना चाहिए. If any question mentions two mutually exclusive events, आपको फौरन क्लिक करना चाहिए कि इनकी कोई intersection नहीं है. Probability A intersection B is equals to 0. Okay. अब आते हैं हम independent events पे. So now what are independent events? Where the occurrence of one event does not affect the occurrence of the other event. Occurrence So occurrence of one event does not affect the occurrence of the other event. These are called independent events. When, oh, hope I wrote this right. Occurrence of one event does not affect occurrence के साथ ना ब्रैकेट में probability लिख लो. Of the other event. इसकी एग्जाम्पल देखते हैं. If you throw a dice and get a 1, उसकी प्रोबेबिलिटी होगी 1/6. दोबारा 1 आने की प्रोबेबिलिटी भी 1/6 है. ठीक है. सेकेंड थ्रो को कोई फर्क नहीं पड़ता कि पिछले थ्रो में क्या था. So all the throws of a dice are independent events. ये नहीं हो सकता कि पहले 3 आ गया तो अब 3 आने के चांसेस कम है. पहले भी 3 आने के चांसेस 1/6 थे, दोबारा भी 3 आने के चांसेस 1/6 है. So throw of a dice is an example of independent events. Example, dice throw. Same is the case of a coin flip. Head आया तो दूसरी दफा head भी आ सकता है, tail भी आ सकता है. ऐसा नहीं होगा कि पहली दफा head आ गया तो दूसरी दफा head आने के chances कम हो जाएंगे. It's not like that. The probability of head or tail would always stay half. It's not going to change. So throw of a coin or a coin flip is also an example of independent events. Another example would be drawing a card out of from a deck but with replacement. Drawing a card from a deck, but very important है with replacement. ये मैं भी समझाती हूँ. With replacement. विद रिप्लेसमेंट का मतलब है कि जो कार्ड आपका आया है आपने डेक में वापस रख दिया. आई थिंक देर आर 52 कार्ड्स इन अ डेक. सो लेट्स से यू ड्रॉ अ कार्ड, यू गेट अ 3. सो उसकी प्रोबेबिलिटी होगी 1/52. फिर आपने वो कार्ड वापस रख दिया तो दोबारा 3 आने की प्रोबेबिलिटी भी वही रहेगी 1/52, या जितने भी कार्ड्स होते हैं. आई एम ऑनेस्टली नॉट श्योर कितने होते हैं. So, if you draw a card from a deck or multiple cards from a deck while replacing each card, तो फिर ये भी independent events होते हैं. अब dependent events की बात कर लेते हैं. Now this will be the other way around. Occurrence of one effect will affect the occurrence of one event will affect the occurrence or the probability of another event. इसकी एग्जाम्पल हो गई कि ड्रॉ अ कार्ड फ्रॉम अ डेक विदाउट रिप्लेसमेंट. Okay, so now if you're looking at probability of getting a 3, तो बल्कि आई थिंक पहले मैंने शायद गलत बोल दिया. 4 3s होते हैं ना, तो 3 आने की प्रोबेबिलिटी होगी 4/52. आई थिंक पहले मैंने शायद 1/52 बोला, वो गलत बोला था. 4/52 होगी. लेट मी क्विकली गूगल के कार्ड 52 ही होते हैं. या 52 कार्ड. अगर ऐसा क्वेश्चन आता है ना तो बताते हैं कितने कार्ड. They don't expect you to have this memorized. Okay, so probability of drawing a 3 the first time would be 4/52. अच्छा, लेकिन अब हम केस कर रहे हैं विदाउट रिप्लेसमेंट का, तो फिर probability of drawing 3 and then another 3 would be different. First 3 की तो probability यही होगी. 4 3s हैं deck में out of 52 cards, so 4/52 टाइम्स दूसरे 3 की अब प्रोबेबिलिटी इफेक्ट हो जाएगी क्योंकि पहला भी आपका 3 आया है. दैट विल बिकम 3/51. हेंस दिस इज द केस ऑफ डिपेंडेंट इवेंट्स. एक पहली दफा 3 आ गया तो उसने अगले 3 के आने की प्रोबेबिलिटी को इफेक्ट कर दिया. अब कम चांसेस हैं 3 आने के क्योंकि पहले 4 3s थे डेक में, लेकिन जब एक 3 निकल गया तो 3 3s रह गए. सो प्रोबेबिलिटी कम हो गई. Now please write down this conclusion. If A and B are independent events, then probability of A इंटरसेक्शन B, इंटरसेक्शन को and B लिखते हैं, probability A and B is equals to probability of A times probability of B. This is an important conclusion. Okay. Now we're going to talk about conditional probability. So what is conditional probability? So conditional probability is the likelihood of an event happening given that another event has already occurred. The likelihood of an event happening given another event has already happened. It has a formula, probability A slash B. Slash is read as given. This is read as given. So A given B has already occurred. The event B has already occurred. What's the probability of event A happening given B has already occurred? This is read as A given B. Probability A given B. इसका फॉर्मूला होता है न्यूमरेटर हैज प्रोबेबिलिटी A इंटरसेक्शन B divided by probability of B. This is the formula for conditional probability. Numerator में you have their intersection and in the denominator you write the lower alphabet. Similarly, if this was probability B given A has occurred. So probability B intersection A upon probability of A. Now we draw an important conclusion from this. If A and B are independent, then what happens to the conditional probability? We have A given B, which is equals to probability of A intersection B divided by probability of B. This is the same formula we just wrote earlier. But if A and B are independent, so हमने independent का ये भी conclusion देखा था कि this becomes probability of A times probability of B. So that means the denominator and probability of B cancels out and you're only left with probability of A. So that means if you have conditional probability of two independent events, then you can simply rewrite this as this. Similarly, if you have probability, let's say C given D, this just becomes probability of C. Only in the case of independent events. Okay. Now let's take a look at few example questions. This is example number 1 from worksheet 3A that you can find in the Drive link. It's I think I've named it Introduction to Probability. Example 1. Events A, B, and C satisfy the following conditions. Probability of A is given to us, probability of B is given to us, probability of B given A is also given to us. B given A, conditional probability है ये कि A हो चुका है तो B होने की probability क्या है. So that's also given to us, and probability B and C is also given to us. This is also written as probability A and intersection hota hai. Now find probability of A and B. This means you have to find probability of A intersection B. अब कुछ स्टूडेंट्स ना इसको इस तरह से गलत कर देते हैं. वो कहते हैं probability A intersection B should be equals to probability of A times probability of B. ये कर देते हैं और क्वेश्चन पूरा गलत हो जाता है. Why is this wrong? Because this equation only works for independent events. इस क्वेश्चन में ऐसा कुछ नहीं कहा हुआ कि कोई इवेंट्स इंडिपेंडेंट है. So you cannot assume they are independent. So no, you can't do this to solve this question. ये बिल्कुल गलत होगा. What we'll do is work with what we're given. हमें एक conditional probability given. हम उसका formula लगाएंगे. So we're given a conditional probability of B given A. This is equals to probability of B and A or B intersection A divided by probability of A. Now we'll substitute the values. This will be 0.45 equals to numerator is what we have to find. B and A या A and B एक ही चीज होती है. So you can rewrite this as A and B divided by probability of A is also given in the question. So now we cross multiply 0.45 into 0.6 gives us 0.27. So probability of A and B is 0.27. This was part A. For part B, we have to find probability C given B. So the formula will be probability C intersection B in the numerator divided by probability of B. So C intersection B is already given, 0.28 divided by probability of B is also given. So 0.28 divided by 0.8 is 0.35. Next is part C, where we have to find probability of A given B. A given B would be probability of A intersection B divided by probability of B. A intersection B हमने पार्ट A में निकाल लिया था 0.27 divided by probability of B would be 0.8. 0.27 divided by 0.8. I'm getting 0.3375. This would be the answer. By the way, this is an exact answer, so it should not be rounded. तो ये rounding गलत है, इसके marks कट जाएंगे. 0.3375 should be written as 0.3375. Do not round that off to 3 significant figures. 3 significant figures में हम long answers round off करते हैं. अगर 4-5 decimal place तक आंसर आ रहा है तो वही लिखना है. और always to be safe, आपने पहले लंबा आंसर लिखना होता है और फिर अगर राउंड ऑफ करना भी है ना तो लॉन्गर आंसर लिखने के बाद करना है. ये गलती नहीं करनी कि सीधा कैलकुलेटर से आंसर रीड करके राउंडेड लिख देना है. अब लेट्स से इफ आई मेक दिस मिस्टेक कि मैं इसको गलत, गाइस गिव मी, Aisha, you asked something, but Wona, I can't see what you asked. So can you text me instead? Okay. So 0.3375 के साथ 0.338 लिख दोगे ना तो ये इग्नोर कर देगा मार्किंग एग्जामिनर और इसका मार्क दे देगा. ठीक है. ठीक चीज लिखने के बाद अगर उसको गलत कर दिया ना तो इट इज स्टिल एक्सेप्टेबल. बट अगर सीधी गलत चीज लिखी तो उस पे मार्क्स कट जाते हैं. ऑलराइट, नेक्स्ट क्वेश्चन. Okay, so this would be example 2. In a group of 100 computer buyers, 40 bought CPU, 30 purchased monitors, 20 purchased CPUs and monitors, and total is 100. Okay, if a computer buyer chosen at random and bought a CPU, what is the probability they also bought a monitor? अच्छा, अब ये पहले तो समझना है ये पूछा क्या हुआ है. If a computer buyer is chosen at random and buys a CPU, what is the probability that they also bought a monitor? ये पूछा हुआ है. Probability CPU given monitor. कि उसने CPU लिया है, given उसने monitor भी लिया है. What is the probability that they bought a monitor? They also bought a monitor. So CPU लिया है, given monitor लिया हुआ था. अच्छा नहीं, I think मैंने उल्टा लिख दिया. If a computer buyer is chosen at random and buys a CPU, what is the probability that also, एक तो इसकी grammar इतनी off है. So it is monitor given CPU. उसने CPU ले लिया and bought a CPU. If a computer buyer choose at random, excuse this grammar, and bought a CPU, ये confirm है कि उसने CPU ले लिया. ठीक है, तो given CPU होना चाहिए. What is the probability that they bought a monitor? So this is the case. Monitor given CPU. Okay. So that would be probability of monitor and CPU divided by probability of buying a CPU. Okay, so that would be monitor and CPU की पहले तो probability निकालनी. So 20 ऐसे लोग हैं जिन्होंने monitor भी लिया है और CPU भी लिया है. तो हमने इसकी probability लिखनी है. Probability will be 20/100. ठीक है, अगर इसकी वर्किंग पहले करनी है we can do it here as well, या directly इधर भी हो सकती है by the way, लेकिन I'm doing it earlier. So 20 upon 100 is 1 by 5. So numerator is 1 by 5. Okay. Now, probability of buying a CPU would be 40 out of 100 people bought a CPU. So that would be 40 over 100 is 2 by 5. So denominator will be 2 by 5. And when we simplify, we get 1 by 2. So you need to understand that this question is asking you about probability of buying a monitor given CPU was already bought. Okay, let's take a look at the next question. Okay. This would be a recap of tree diagram that you've already done. Okay, so this is an IG question, but we need to do it so that we are able to understand the other questions on tree diagram. Okay. All right, so Dan either walks or cycles to school. So we can see that in the tree diagram. साइकिलिंग की प्रोबेबिलिटी बताई हुई है 1/3 और वॉकिंग की प्रोबेबिलिटी नहीं बताई हुई. And I hope you remember this from O levels. If this is 1/3, then the rest of that has to be 2/3 क्योंकि total probability 1 होती है. So if you do 1 minus 1/3, you get a 2/3. Okay. Dan either walks or cycles to school. Probability that he cycles to school is 1/3. Write down the probability that Dan walks to school. हमने लिख ली 2/3. When Dan cycles to school, the probability that he is late is 1 by 8. इसकी बात हो रही है, इस लीफ की बात हो रही है. If he cycles to school, then the probability that he is late is 1 by 8. अब ये information दी हुई है ना, इससे we can just fill up this part easily because the sum of a branch is always 1. So if the upper one is 1/8, the lower one has to be 7 by 8. So this would be 7 by 8. So if he's cycling to school, the probability he'll be late is 1 by 8. And if he's cycling to school, probability that he'll be not late would be 7 by 8. So if this is 3 by 8, then the sum needs to be 1. So that has to be 5 by 8. Calculate the probability. Achha, we had to fill up the tree diagram for part B. We're done with that. Part C. Calculate the probability Dan cycles to school and is late. That means they're talking about this whole branch. Cycles to school and is late. And जो होता है ना वो हमेशा multiply होता है. So Dan cycles to school and is late would be cycling की probability 1/3 and means multiply. Late होने की फिर probability है 1 by 8, so 1 by 24. Part 2 is find the probability Dan is not late. Now they are talking about the cases in which he is not late. दो cases में not late होता है. एक तो cycle करके आया है एंड ही इज नॉट लेट, एक ये वाली पूरी ब्रांच लेनी है, और फिर वॉक करके आया है एंड इज नॉट लेट, ये वाली पूरी ब्रांच लेनी है। ठीक है, शुरू से ब्रांच लेनी होती है और बीच में ना इन दोनों के प्रोडक्ट्स निकाल के ऐड कर देना होता है। सो वो पार्ट 2 यू विल डू साइकिल एंड नॉट लेट और इज प्लस वॉक्स एंड नॉट लेट। ठीक है, दोनों केसेस को ऐड करना होता है। सो 1/3 टाइम्स 7/8 प्लस 2/3 टाइम्स 5/8. That would be 17/24. And part 3 is, अच्छा part 3 is not from O levels or IGCSE, ये मैंने खुद डाला है इस क्वेश्चन में. Dan cycles to school given he is not late. Probability that he cycles to school given not late. इसका फॉर्मूला लगा लेते हैं. This is conditional probability. Probability cycles and not late or intersection divided by probability of not being late. Not late. Okay. Not late की probability part 2 में निकल चुकी है. देखो, Dan is not late, वो ये probability थी. So denominator आपको पहले ही पता है, 17/24. Okay. And then cycles and is not late is this part. Cycles and not late. So इसकी probability numerator में लिख लेते हैं 1/3 times 7/8. Now we enter this in the calculator. 1/3 times 7/8 upon 17/24. 7/17 is the answer. ओके, ये रिकैप इसलिए कराया है ताकि अगले क्वेश्चंस में आपको ट्री डायग्राम खुद से बनानी आए, बिकॉज इन ए लेवल्स they don't give you the tree diagram, they expect you to make one on your own and then do the working on it, unlike in O levels where they would give you a tree diagram or a structure at least to work with. So this is what an A level question would look like. So you will have to make a tree diagram on your own. It is known that among all patients displaying a certain set of symptoms, probability that they have a particular rare disease is 0.01. Probability that they have the disease is okay is 0.001. ये बता दिया. That means probability that they do not have the disease, I'm writing no disease or do not have the disease. इसकी probability क्या हो जाएगी? 1 minus 0.01, which would be 0.999. ये खुद से लिखना है, ये क्वेश्चन ने नहीं बताया, हमने खुद से डिड्यूस किया. So probability के एक पेशेंट को डिजीज है इज 0.01 और प्रोबेबिलिटी के उसको डिजीज नहीं है इज 0.999. A test for disease has been developed. The test shows a positive result on 98% of the patients who have the disease. तो अगर डिजीज है तो पॉजिटिव रिजल्ट आने की प्रोबेबिलिटी 98% है. 98% is 0.98 क्योंकि probability 0 से 1 तक होती है. So if a percentage is given, you just divide it with 100. So if a person has a disease, probability that the test result will come out to be positive is 0.98, which means that the probability of the test result not coming out positive, that is negative, would be 0.02. 1 minus 0.98. And on 3% of patients who do not have the disease. अब अगर disease नहीं है तो positive आने का result का positive आने की probability 3% है. That means 0.03. Which means you'll also write that negative आने की probability है 1 minus 0.03, which is 0.97. So some information would be given to you in the question. Some you will deduce on your own by subtracting the given probability from 1. Tree diagram खुद से बनेगी. They'll not give you the tree diagram. So let me just quickly recap the tree diagram. Disease होने के chances 0.01 है. Disease होने की probability और disease ना होने की probability 0.999 है. अगर disease है और टेस्ट कराया है तो उस टेस्ट के पॉजिटिव आने की probability 0.98 है और नेगेटिव आने की 0.02 है. एंड द अदर वे अराउंड, अगर डिजीज नहीं है तो पे पॉजिटिव टेस्ट रिजल्ट आने की 0.03 probability है और ना आने की 0.97 probability. Okay, now we'll read the question that they've actually asked. The test is given to a particular patient displaying the symptoms and it is recorded as positive and it records a positive result. That means given positive आ गया कि result positive आया है, find the probability that the patient has the disease. तो हमने find करनी है probability disease given positive result. This is a question on conditional probability and you have to find probability of disease given positive result. Which means we'll do probability of disease and positive divided by probability of a positive result. Okay. So disease and positive के लिए तो हम इस branch को follow करेंगे. Disease है और positive result है. So we'll multiply these two. 0.001 into 0.98 divided by the result is positive. अब इसके लिए दो branches follow करनी पड़ेंगी. इस branch के भी end में positive है और इस branch के end में भी positive है. So we'll have to find both these products and add them. So 0.001 times 0.98 plus 0.999 times 0.03. So numerator would be 0.001 times 0.98 divided by 0.001 times 0.98 plus 0.999 times 0.03. 0.03166,397. Now I've written a long decimal answer for the examiner. Now I will round it off to 3 significant figures. Yeah, my answer. Okay, that would be all for today. Kuch homework questions aayenge, I'll let you know in a bit. Take care. Thank you for joining. Allah Hafiz. If you have any question, you can stay back.
Allah Hafiz.